very much for coming today and attending my talk on Sharding Adventures. My name is Herve Roggero. I am a Microsoft Azure MVP. I've been for 5 years now an MVP in the Microsoft Cloud, and I love everything cloud. Today we will talk a little bit about cloud computing eventually at some point during the presentation. However, the focus of this presentation is really real-time data access of multiple data sources. So before we begin, I want to set the stage a little bit about what this is going to be about. Imagine you're a bad guy. So let's say you're in the Matrix and you're the architect, and you have to control one machine. Well, that's not too complicated, right? You just have really one machine. You have one API to worry about, one endpoint. Nothing too complicated. However, as soon as you want to plan an attack and you're dealing with tens of thousands of machines, now you need to worry about how you're going to control all this environment and all those machines and all those individual endpoints to be able to stop them if you want to start negotiations, start them again, or start the attack if you want to launch the attack. What about controlling just a small group or a subset of those machines so that you can actually give them a directive or an objective? So really, sharding and the concept of data parallel access is on virtually every movie that we deal with and we look at when we're talking about sci-fi. So ultimately, there is actually more than just a number of machines that we want to talk to. We have another problem if we are the architect. We have not only the Sentinel that we need to talk to, right? But we also have Agent Smith and the other programs that are out there. So we have a variety of programs. And then just, wait for a second here. So we've got machines, we have programs, and of course we use now revisions, different models of, versions of the program, different revisions, different updates. And of course, we have other machines that we need to worry about, like debug, right? So really, it becomes really, really complicated. We not only have a problem of quantity, but we also have a problem of disparity. So with that said, really, Neo, nails it just right. When he sits down on that machine, I know Kung Fu, right? It's great. It's the best line, I think, in that movie. And what does that mean? Well, he removed the learning curve of Kung Fu, right? It could take you 15 years of learning multiple times with multiple masters, multiple instructors, and poof, suddenly in 10 seconds, he knows Kung Fu. Isn't that great? So imagine, I'm sorry for the geeky joke, but imagine you're sitting on the chair at work and go, oh, I know Twitter. I know Facebook, right? Right? So this learning curve, all these APIs, right? If you go on if you whatever project you're working on, the API is the boundary. The API just gets you every time. What can you do with it? How does it work? Is it REST? Is it web services? Is it a flat file? What is it, right? And then, of course, how do you authenticate with the thing? And you would think, well, if it's all REST, then it's easy. We can authenticate with all those endpoints. No, every single REST endpoint has a different authentication mechanism. It's all based on standards, but all the standards are implemented slightly, differently. Look at even if you stay within the realm of Microsoft, dear Microsoft, and you're trying to authenticate against a SharePoint Online. Well, then try to authenticate against an Azure storage and try to code this. It's different. So if we go back in time a little bit, we're working on a project, Enzo Unified, which attempts to really simplify things a little bit. Let's talk about that. And in the context of sharding. So let's take the red pill, shall we? In my opinion, the ability to solve communication to a wide variety of machines and enable real-time communication to a wide variety of systems you have to first solve the problem of eliminating the APIs as much as you can, so that you no longer have to worry about the protocols, you no longer have to worry about the format of the individual data sources that you're dealing with, and making it easier to access your data. And then you can shard. So for example, let's take a couple of examples. The majority of systems, first of all, before I dive into this, who's played with parallel data access or sharding with databases? All right. Who's played with sharding with things other than databases? Right. So, sharding is a concept. It applies to a variety of things, not just databases. It happens that sharding databases is more natural and a little bit easier. It's the easier problem to solve. But you could be sharding no-sql tables. And you could be accessing no-sql tables in parallel. You could be sharding access to flat files. Let's say you put your hands on the tobacco distributors in Florida, in North Carolina, in South Carolina, and you have various files from the government that gives you access to this information. Well, you might want to be able to access all this information in parallel at the same time, right? So it's not just databases, it's flat file. What about APIs, API endpoints? And who talks about API? Of course, we talk about IoT. What about accessing watches that people wear for healthcare monitoring? What about accessing those things in parallel at the same time in real time? So it's not limited to accessing databases. It really is accessing just about anything. That's what we're talking about today, which means hybrid type of sharding. So it's a tall order, and I'll show you how we're trying to accomplish this. So I tried that a few years ago, and I wrote a software shard that really relies on an SDK. So if you try to solve this with software only, then you have to build an SDK, and then you have to give it to a developer so that it's built into the code, and then the SDK really kind of is on all the machines that need to access your shard. So in this example, if I have a shard made of multiple databases, to keep it simple at first, then I would need a configuration database that my SDK needs to connect to so that it knows, here is your shard map. Here are all your databases that you can connect to. And then the SDK will try to hide the complexity of all the things taking place behind the scenes to access its data in parallel. But I think that's a problem. It's very complex to do, and it's the easiest way to solve the problem without better tools, but it really is challenging. What if your shard configuration changes quickly? So what we're trying to do, and what we have done, is to build a shard as a service. It becomes a serviced shard. So it's something you can connect to, which then hides the real complexity of your map behind the scenes. It becomes serviced. You can think, yeah, is it a web service? Yeah, it could be. But it actually could also be a database server, right? In this case, if it's serviced, you no longer have this configuration database. The shard is part of the definition of the service, right? So a couple of examples. One is fan-out queries. I'll talk about other things later, but a fan-out query is a term that we use in sharding to describe the fact that we want to spread a request or a query across multiple databases or multiple endpoints at the same time. So we're fanning out the request, right? If you have a software shard, then every client is, with the SDK, connects to the same configuration database. And you're kind of hoping that all these clients have the same definition at the same time, because you need to refresh in the background. It's complicated. If you're using a service shard, you no longer need an SDK on the client side because you're connecting to the service. And then, of course, you have, how complex can it be? Well, there's a couple of problems we talked about, right? We have, first of all, how many data sources are you talking about? Are you talking about 1 sentinel or 10,000 sentinels? And then how uniform is your shard? Is this just sentinels? You're dealing with a variety of devices and endpoints. So when you have lots of data sources and hybrid environments, you're dealing with an extremely complex shard. Some data sources may be read-only. Others may be read-writes, right? Maybe the service can cache information for you so that information can get to you faster. So it can get kind of hairy. So Enzo Shard is what we're building, and it's a prototype. Think of it as a proof of concept that not only eliminates the APIs, so that you no longer need to understand the underlying APIs of the devices or endpoints that you're dealing with, but it's also serviced in the sense that you can connect to it directly as a database, a virtual database, or as a REST endpoint. So what we're trying to do is to basically solve these problems. Object independence. It doesn't really matter what the name of the table is. If it's a NoSQL table, a database table, a flat file, it doesn't really matter what it is. We're trying to make it semantic independent so that whether you need to connect to one as a REST endpoint and the other one as a SQL endpoint, we're going to make it uniform for you so that there's only one language to use to access them all. Protocol independent, so related but similar but related, right? Is it REST? Is it SQL? Is it TDS? Is it flat files? And central authentication, which we talked about earlier, so that there's one way to authenticate across all those data sources. Let's take a first example of accessing one file, which we're going to create two views on a file, and accessing, it's really the same file, accessing two flavors and two views on the same file so that we can see how Enzo works. So what I'm going to do is jump over to SQL Server Management Studio. Uh-oh, I have technical problems. Ah, that's why. It's there. Woohoo. Aha. So, this is SQL Server Management Studio. And as I mentioned, Enzo can behave as a web server, kind of a REST server, really, and also as a database server. So in this case, we're going to connect to Enzo as a database server, and we're going to use SQL Server Management Studio as our test front end, if you will. It could be anything else. It could be ADO.NET. It could be whatever. So let's connect. And I just want to show you first an example of a way to connect to Twitter without necessarily understanding the API and the complexity behind Twitter. I'm just going to do a select star against a virtual table that we call Twitter and accessing the timeline of Twitter to see what the current Code on the Beach tweets are all about. So I'm going to press F5, and of course, authentication comes up. Who are you? Right? And so it's a database, virtual database server, so it connects for you, but it needs to know who you are. So let's connect to Enzo. And this will run connect. Aha. Did I? There. And it returns the tweets in real time that are right now. If you go on Twitter and search for Code on the Beach, this is what you would see, right? So we've got a few tweets here. And it's, of course, because it's real time, it's not just read-only. We can actually post status. This is a live demo of Enzo at Code on the Beach, right, with the Twitter API. So same thing. We authenticated. We communicated through Twitter in real time and made it look like a virtual table, right? So same thing, we can actually communicate and send a tweet in real time to Twitter this way, and this is it. Now, if you go on Twitter, you'll find this. So this is the API standardization that I'm talking about, removing the complexity of both API management and authentication, depending on what it is you're trying to connect to. Now, this is interesting for two scenarios. One, to be able to consume data, depending on variety of data sources you want to consume, but also to expose your data so that your consumers of your data can consume your data a lot easier now, right? They don't need to learn your APIs anymore. So there are other adapters. For example, this is an Azure storage adapter. It'll list the content of that particular table, Enzo config. So same thing, same concept, except now we're talking to Azure Storage. So we're talking no-sql here. Authentication, no-sql transformed into raw native SQL data. Here is a CSV adapter connecting to a local file, but it could be FTP as well, and makes the file look like a virtual table. I think you guys now get the concept. So it really doesn't matter what it is. Enzo will make it look like a raw native SQL endpoint, or REST endpoint. We'll do this at later for in the demo. So let's see. We have what we need to understand next is the general configuration of the shard. So now let's take a look at the shard. Well, we can make an API endpoint look like a virtual database. Now let's talk about the shard on how to connect to those things. So we have a configuration table where you can define data sources and shards, and a shard being a collection of data sources. We'll take a look at this a bit more closer later. But ultimately, this is what I meant by the configuration. It's built into the system. So we can connect to, let's say, to this particular file, which is this file. Now, that happens to be the tobacco distributors in question. And I can select from the first file and retrieve the BJ wholesale in Florida. This is actually from a data file provided by the state of Florida that I downloaded on my local machine for performance reasons. And this is the same statement, but I'm filtering with Sam's Club. So I have two views, one that points to Sam's Club in Florida, the other one to BJ's in Florida. I'm just pointing to the same file for now. It's a simple demo. And then what I do is I'm going to create a virtual table to point to my distributors, which are Sam's Club and BJ's. So I'm creating a virtual table in Enzo. And now Enzo has created for you a table that doesn't really exist, but it's a pointer to two views that will point to the actual data. So I can do something as crazy as select star from Shard Tobacco Distributors, where location is Jacksonville, for example. And this will send that request in parallel to those two views, which will fetch the data and combine it for you. Aha, sorry. There. So the second example is instead of accessing files, we can also access, of course, databases, right? There's no reason not to. So in this case, I will actually connect to two local databases. And I chose to do local tests simply because it's better for performance demonstration purposes. So I'm going to create a virtual table called local sales, because I want to connect to local databases. And basically below, I declare a schema of how I want the data to be returned for that particular shard. So now if I do a select star from all sales, what's going to happen is that this is actually going to go after my two local databases, return the information that is behind local sales, which is select statement or views that I've declared before. And beneath this, you'll see where the data actually comes from automatically. So it will add a column dynamically to tell me which record came from which database, either DB1 or DB2, so that I know where my data came from. You could also say, well, I want to query just DB1, sales DB1. Before we do that, let's connect and say, retrieve to me all records from my entire shard, which is now just two databases, where ID, the record, the column ID has a value of 1, it will go send a request across both of them and filter the records for you and say, I've got one record in each source. And of course, you can say, no, I just want really the ones in sales DB1. And it'll point to just the correct source of, that you've selected. You can also set context so that you can access information directly a different way. So I'm actually going to go back to this in a minute. So what I'm showing you here is how this particular shard, we're going to build this shard a little bit in more details with more data stores and more sources of data. That's going to be more hybrid in nature. So what I've shown you so far is 2 databases that actually contain a sales history table each that I combine behind a virtual table. And I'm going to add a flat file to that, which contains also additional sales information, but contained in the flat file. These red dots here, or squares, actually correspond to a data source definition. So Enzo has a configuration of those data sources. And I am going to create a recent sales virtual table, which will point to those 3 data sources. And I'm doing this because really these are local databases and a local file. So this is actually high performance. It's all local. And then I'm going to add access to an Azure table, which contains also additional sales history information. And I'm going to create on top of that another shard called all sales, which will point to both the Azure table and the recent sales shard. I'm cascading my shards. Now, the advantage of that is that you can remove or add through configuration endpoints to recent sales. You won't have to modify all sales. It'll dynamically figure out the configuration of your entire shard. And what this means is once you've created an all sales virtual table, you'll be able to do select star from all sales, and it will spread the request progressively through the entire shards and collect this information into a single data set. Again, we're doing examples with SQL. We'll do the same with REST later. So seeking a partition, it becomes really important. Where do I send my command? At which level in my diagram am I commanding here? Am I sending at the top level? Am I trying to select records to my local databases or just to a single data source? What about updating records, inserting record or deleting records? Same thing. I need to understand what the context of the command is going to be if I just do a select star, right? At which level do I want to send my commands? So there's actually 3 ways. An explicit declaration saying set context, which will force all future commands to a specific layer or level in my shard. Let's say just one database or just my local databases. So at the session level, that's when you know what you want to go after. But maybe you don't know exactly where you want to go after. Maybe you just want the shard or the endpoint where order ID is 1000, wherever that is. It could be in any of them, right? Return to me the first one that contains that record. So that's more of a dynamic selection of your session. And we have a mechanism that allows you to do that, where you run a statement that will select the correct shard for you where your record is located. And last option is, no, I don't want to change the session. I just want to run that command only against that shard, which I've done a little bit actually earlier. And we have modified the SQL syntax a little bit to add an @ sign that says, that's the table I want to go after, but only in the context of that shard or that data endpoint. So you don't have to switch your entire context. All right, so now let's go after reading and writing against multiple sources of data. Let's see. This is the examples on how to do the set connect. So you can do a set context over here so that that statement runs against just sales DB2. So let's try that actually. Now it's changed so that that particular statement will go against local sales, but only against sales DB2. Only one record, right? Or you could say, I'm about to set a dynamic context, but I don't know exactly what my database is going to be. I just want to select my database where ID is 1 and customer ID is something else. And it will say, I found this in sales DB2. So now you can set that flag off, and now you can execute the same command. That's in case you're not sure where that record is, right? So you can point your context wherever you want it to be. Let's clear the context so that we go from the top of the shard. And then we can update records over here. So let's say I want to do an update. And this is updating a local database, so there's not a lot of magic here going on. Select star from local sales, where order ID is 201. There's actually 2 records that match that particular command. Both of them are in sales DB2. So you can actually send a command to update local sales and change the category to tennis instead of sport, where order ID is 201. So if you run that command, this will actually execute and it's done. So if you do a select star from this, you will now get tennis for the category. So of course, I'm working here on an actual data source in my shard. You can send the command at the entire shard level and let it figure out where those records are. You could do at the statement level I mentioned earlier. For example, if you want to send the update command just to that one shard, you can do that as well. All right, so what we're going to do now is accessing a flat file as well and accessing our Azure table. So what I'm going to do is create a virtual table against called enterprise sales, which is pointing to all sales, which is our shard all the way on top. And that will send all commands to both the local databases, the flat file, and the Azure table, right? So now that we have created enterprise sales, we can query enterprise sales different ways. We can say, select star from enterprise sales at recent sales. So now this is pointing only to my local environment. And you'll see that I'm accessing DB02, DB01, and my sales file at the bottom. Okay, so now I have records coming from 3 environments. Or let's make the request to point directly to Sales Azure. Let's get our Azure records. They're here. We have a problem. We have a difference here, right? We have a partition key and a row key because Azure Tables requires those 2 columns. So right here, we're starting to see some variance of how my data is going to look different depending on the data source that I'm connecting. So if I do a select star from shard enterprise sales, and I'm going to go after all of them. At this point, I'm connecting to my local databases, my flat file, and my Azure table. And I have the records being returned here. Notice that we've added partition key and row key everywhere, and even a timestamp. That's because an Azure table has all 3. So dynamically, the system has to add the columns because they exist somewhere. They have to exist everywhere. It just plugs null values where they don't belong. So if we look and inspect this particular statement, the result set, we can see that our partition key and row keys are null everywhere except for the records coming from the cloud, coming from Sales Azure. All right? So we declare a schema, which is what we want the table to look like, but that schema can expand based on the data sources that we're hitting. So let's say we want to find all records across our entire shard where customer ID is 1. And it will go and execute that statement across all data sources in our entire shard. So we could do the same thing and update a record like we did before by setting context. I'm not going to do this again. You may ask, well, what about updating the flat file? Wow. The flat file was declared as read-only in my configuration, so that it knows to skip the flat files when I run create, update, or delete operations, right? It's smart enough to know that. And what about the cloud? What about my Azure table? Can I also send an update statement like this? So the short answer is yes, but. The but here is because we have a partition key and a row key to worry about, right? We must specify a partition key and a row key when we delete, when we update, and when we insert. These are required elements. And my current virtual table doesn't have that. So we have a provision for that where you need to create a virtual table that points just to the Azure table so that you can update your data in the cloud, right? But ultimately, it's the same. I'm going to skip a couple of things here for the interest of time. But as you can see, I have examples on how to insert. So where is it going to insert? It depends where you're pointing. Right? If you're pointing at the top, it's going to try to insert everywhere. So it's a way of distributing your deletes, your updates, your inserts, so you don't have to know where your records are. Of course, it's slower, because it has to spread that command everywhere. Or you can point to the specific shards that you want to perform those update operations. So here I have a virtual table for the Azure Enterprise cells. I'm just going to run this. So it's created, but I'm not going to use it just at this point. And these are examples that I can show you later if you're interested on how to perform updates, insert, and delete on Azure tables through the same commands. There is a built-in help so that you can see the way those particular commands are created behind the scenes. And there is a way to access logs so you can see how long these commands are taking. So there's actually logging information behind the scenes as well. All right, back to the presentation. So I showed you how Enzo can abstract communication across multiple endpoints and multiple protocols and make it look like a single thing, right? A virtual thing in real time. Kind of important. What about SQL Server then? Can SQL Server believe that it's dealing with a real database? What about accessing from triggers, stored procs, functions? Can a trigger actually call a shard to figure out if records are valid, for example, for data validation? Yes, it can. Enzo really, in this particular environment, it looks like SQL Server. So it's not SQL Server, but it looks like SQL Server. So we can definitely use SQL Server linked servers and issue a request against a linked server to access our shard. There's a quick demo here. Link server demo. There we go. And we're gonna send a command to the local SQL server, which we're gonna connect in a second, which will connect to our link server called localhost 9550. This is where Enzo is listening. So SQL Server will actually communicate, authenticate, and communicate with Enzo and access our enterprise cells, which connects to the local file, local databases, and an Azure table. So now we're connecting to SQL Server. So let's connect to the local instance. That should work. And at this point, SQL Server authenticated against Enzo and executed the virtual table we created dynamically earlier that will spread the individual commands to the various data sources and make it look like it came from a database. And we have the source information, so we know it's coming from the real stuff. So what can you join and say you have a local users table with stainless steel, roast beef, and Handyman? All right, I know it's bad. And you can do things like that. Select distinct, last name, first name from, from this particular join, which will join my local, let's say, CRM table, and join into my shard, enterprise my virtual table, and resolve the first name and last names where the state is Florida. Apparently, I can only resolve 2 names out of all the customers that I have in my database. So I've performed a join of a local SQL Server database through SQL Server to my virtual environment. So there are, of course, some serious performance implications. Right? It's not something you deal with lightly. It's fast when you know exactly when you want to go in your shard. It gets slower the more you spread your information and the farther your information is stored. If you're connecting to an FTP site to load a flat file, you'll have to wait a few seconds. It's still real time, but it's a little slower. So there are certain things we're doing about it. One is to provide an edge cache. So you can actually load and prefetch information that will give you local cache access to this information, and it will refresh automatically in the background. That's a state file. A state file from, for tobacco distributors doesn't change every hour. It changes every day or every other day, so you can put a cache mechanism to automatically refresh behind the scenes. And your data is always local, right? Partition filters, knowing where you want to send your request is really important. It really helps speed the commands. There's also an async mechanism. You can send an update, a delete, or an insert record, a statement, and just let it fire off asynchronously, and then you can check back later, are you complete, and what is the status? And then cascading requests. If you've got, let's say, 500 endpoints, or more or less, then one server is not going to be enough because you can only do so many parallel requests at the same time. So cascading Enzos and cascading virtual databases is really what you want to do to do multi-node distribution. So in this case, I'll show you how Enzo communicates to 2 other Enzos, which will send their command and fetch it back. So you can spread those requests out. You can imagine some of them could be in the cloud, on premises, it doesn't really matter. And your shard definition can be spread over multiple Enzo endpoints. Because Enzo looks like a database, it's easy to spread them out. So make sure. Yeah. All right, what I have here is an example connecting to Azure tables. I've got 2 Enzos configured on the same machine, 2 more Enzo configures on the same machine. Let me show you real quick. So you can visualize this. If I can find my mouse. It runs as a service. So Enzo Unified is the primary service, but then it connects to 2 other services, so we spread those requests. And in this particular example, what I have is each Enzo is configured to point to 2 different Azure storage environments. So I actually have 2 storage accounts configured across my Azure environment. And one connects to an environment called Blue Syntax and the other one called BSC Dev. These are 2 storage accounts that I have created on each instance of Enzo. And I'm going to create a virtual table that will communicate to those 2 Enzos, which point to different storage accounts. So now when I do a select shard from Azure Movies, which is the virtual table I just created, but just point to Azure Blue Syntax, this will point to my one of the instances. So I can actually get the movies coming from one of the Enzos. Star Wars, The Big Blue, and The Matrix. Oh, I don't know why The Matrix. And then the other configuration in the other Enzo returns Batman, Lord of the Rings, etc. So if I actually connect to I'm local here, and I'm saying, run against my virtual table, which points to the other 2 Enzos, and collect this information from those 2 storage accounts into a single output. And here we go. It's pretty fast. This is live, huh? So we talked about REST. Let's deliver on that. Enzo can look like a database server, and it can look like a REST endpoint. So now with a REST endpoint, as you can imagine, you can connect to the same virtual tables that we talked about, that we created, which will make all this thing work and come back as a REST result, as a service. If I can find my advanced REST client, there. Oh. Where is it? I lost it. Lost it. It's hard sometimes without a mouse. Sorry. I don't quite understand what's going on here. It's bizarre. I can't. It's gone. Well, I'm sorry. My Google Chrome instance has disappeared from me, and I can't seem to be able to get it. It's hiding behind my Windows bar at the bottom. So if you want to see a REST demo, you can come and see me later, and I can show you how to do this. I'm sorry for that.
Can you hit the Windows key and arrow over to it, and then hit Command up arrow, and make it maximize?
Oh.
You might be able to tap to it.
Yeah. Oh, but it's when I minimize, it goes all the way down.
Yeah. If you can get it selected, though, you should be able to maximize it.
It is. Yeah, I have it on my other screen. So. Yeah, I have it. It shows up here, but now I need to put it there, and every time I resize it, it disappears. So it's here. Look, I'm kidding. It's right. How do you do the projector thing? So we see all P, duplicate, right? How about that? Woo! All right, so we're connecting to our local host. This is the IP address where Enzo is listening on the REST endpoint. And we're sending a command to BSC, shard, select Azure Movies. Right? We have the Azure Movies virtual table. There's actually a select Azure Movies behind the scenes that works. And we're sending an authentication token, which is an application identifier, if you will, and sending the request to Enzo this way. So it really is a very friendly REST thing, right? We saw the SQL command, which was bsc dot shard dot this is what this is. So it's sending there and saying, send me and execute that command against Enzo. And it returned a JSON result of my movies, all of them. So we've successfully sent a shard request to Enzo. Using this particular, using a REST endpoint. Same thing, right? So your configuration works as a virtual database and a virtual REST endpoint for mobile development, if you want. So sharding applies to more than databases. It's not just relational databases. And it's just not easy. There's a lot of things to worry about. There's lots of details behind the scenes that we're not interested in today. But at the end of the day, it really simplifies the data ecosystem, which is what this is all about. And I think that now that I'm playing with a service shard, it's significantly better, faster, more flexible. You can cache, you can centralize authentication. You can do a lot of things with a service shard that you cannot do with an SDK type approach. And now, you know Kung Fu. Thank you. Any questions? Clear? Clear as mud, yes? It's another table inside Enzo. And you can, you have commands to be able to manage your configuration settings on the fly. And it has a connection string if it's a database. It has whatever makes sense for the endpoint that you're communicating to. Yeah.
reader, and you have all this configuration inside.
Yes, that's right.
Just a record.
It's just a record.
And that shard is a procedure or something.
Yeah, so the shard is a virtual, basically it's a virtual database that manages all this configuration behind the scenes and spreads the requests wherever they need to go.
Pretty cool.
Thank you.
The service is just an individual service. It doesn't have to have anything that plugged into the SQL Server.
So it uses SQL Server Express for its own configuration internally, but the service itself basically looks natively as a database server and a REST endpoint. Yeah. All right, cool.
You do like multi-tenant applications?
Yes, that's right.
And have a shard for each one of your customers?
Yeah, they're not being used as a shard, but we have multi-tenant REST access for a couple of customers that need mobile access to these environments to simplify API access.
So how many different shards can you?
I haven't actually tried to see what's the boundary. It really highly depends on the volume of data you're talking about. For large data sets, I would imagine you would probably need multiple shards. But everything we've done so far is relatively small data sets, so everything usually can be contained within a single instance. And because it's stateless, right, you can really load balance this on multiple servers if you wanted to. Yeah. Although it looks like a database server, it's not. It pretends to be, so it's entirely restless. So you could really load balance across multiple Enzos as if you were load balancing across multiple database servers, which you cannot do with SQL Server, of course, because now that contains state. We don't. Right. Yeah, it was a lot of work, but it's a lot of fun. All right, thank you so much, guys. Thank you.